So this is a solutions video to math skills review, and the first problem we want to do is basic arithmetic. We want to find all the prime factors of 210. There are a number of ways to do this, but the idea is to not use our calculator, so I'm just going to make a little tree here. The idea of a tree is you just sort of break it into factors, two different factors. So like this one is obviously even, so it's 2 times 105. And so 2 times 105 is 210. Now 2 is prime, so maybe we'll circle it, right? Since it's prime, there's one prime factor. And then we can rewrite 105. 5 obviously goes into it 21 times, because 5 times 20 is 100, so one more 5 is 105. And then 5 is also prime. You can't factor it anymore besides 1 and 5. And then if you look at 21, we know 21 is 3 times 7, and both 3 and 7 are prime. So those are our last two prime factors. So the prime factors of 210 are 2, 3, 5, and 7. The next problem has to do with order of operations. So remember, order of operations, there's a certain order that you apply each of these operations: addition, subtraction, multiplication, division, exponents, and the parentheses or absolute value. They group things together. So these, the way I remember this is usually PEMDAS. And what it stands for is parentheses come first, and then we have exponents are next, and then we have multiplication and division. Now these kind of go together. It's not that multiplication comes first or division comes first. It's just we do these usually from left to right. That's the best way to work it. And then we have addition and subtraction, and then these are the same way. They kind of are together, and we just work them left to right. So let's take a look at our problem and ask ourselves a question: do we have any parentheses? And we certainly have lots of parentheses. These square brackets are parentheses. These are actually what we would think to be parentheses. And then absolute values also sort of an implied parentheses. So here what we would do first is we'd work within inside these square brackets, and then within inside these square brackets we have absolute value or these parentheses here. It really doesn't matter which one you do first, so I'm going to go from left to right. So what I have is the absolute value. I'm going to work in there first. So 7 minus 19, so that's negative 12. And I just do one step at a time. That way I try to make sure that I don't make any mistakes. So 3 times 12 minus 7 times 2 in parentheses, square bracket, squared. So I'm just copying down the statement. So that's equal to the above statement. And I reset. So parentheses again, you still have these square brackets, so I go inside there and I still have the absolute values. So absolute value of negative 12 is positive 12. So let's write down positive 12 divided by 3 times left parenthesis 12 minus 7 times 2 in square bracket quantity squared, which is equal to, so now I did the absolute value by dropping off that negative sign and making it positive 12. So the absolute value is done. So now I can move on to these parentheses right here, or this set of parentheses right here. And so then this is 12 divided by 3 times, and then inside this set of parentheses you have 12 minus 7 times 2. So again, you restart PEMDAS, and the first thing that comes is multiplication. That's relevant here. There are no parentheses or no exponents, so we do 7 times 2, which is 14. So 12 minus 14 in parentheses square bracket quantity squared is equal to, and again we're still working inside those parentheses, so 12 divided by 3 times, now 12 minus 2, 12 minus 14 is a negative 2, so we have negative 2 here in square bracket quantity squared, and then equals. Now you still have this set of parentheses, but the reason they're there is to offset that negative sign. There are no further operations to be done inside. So what we really have is this division and then this multiplication. And since they go together, these really go together, it's not like multiplication comes first. What we do is we always work left to right. So this is where it gets a little bit tricky, because oftentimes I'll want to multiply here first because they're just closer together. But that would be wrong. The correct operation is to divide by 3 first. So you really have 12 divided by 3. Because again, you work left to right when it comes to multiplication and division. So what you get here is 4, because 12 divided by 3. 12 divided by 3 is 4, and then times negative 2 in parentheses, square bracket, quantity squared, which equals, so now I have 4 times negative 2, which is negative 8, so I get negative 8 quantity squared, and that's equal to 64. Right. And what's really nice about this problem is if you're ever in doubt of your order of operations, you can always check it on a calculator. So if you make a silly mistake, maybe you can go back and find it and figure out how to correct it. I was waiting for this thing to open up so you can see it. Okay, so on this one, let's clear all this out. And so we can put this in, so you have basically left parenthesis and then absolute value. If you hit math and hit over to number, you'll see there's an absolute value, ABS, and so I'll hit enter on that. And then I'm going to hit negative 12. Sorry, not negative 12, but 7 minus 19, so 7 minus 19. And then hit over to get out of the absolute value, and then divided by, and then I have 3 left parenthesis, 12 minus 7 times 2, in parenthesis, raised to the 2. And if I hit enter, I should get out 64, and I do, so I know I applied the order of operations correctly. So I got the right answer. So you can use your calculator to check your work. But it's really important you understand order of operations, because we will be putting sort of complex expressions into our calculator, and if you don't, you're going to have a hard time with those types of problems. Okay, so the next problem involves fractions and power. So we'll start with fractions first. So these are always sort of an issue in the beginning, making sure you know your times tables and how to add and subtract and multiply and divide fractions. So let's do this one. So what you want to do when you work with fractions and you add and subtract, you have to make sure you have a common denominator. The idea, excuse me, the idea is you can't add a fifth to a ninth, because a fifth and a ninth aren't the same thing. It's sort of like adding a dime to a nickel. You really can't add dimes to nickels. You have to first change them to cents, and so you say a dime plus a nickel is 15 cents. Right? So you find a common denomination on money, which in this case is pennies, cents, and then you can talk about them. You can add them together. Same thing happens with fractions. A fifth is not a ninth, so what you need to do is change this into a common denomination, or get a common denominator. So what we'll do, it's real simple, so you want to have something in the common on bottom, so we'll put a 9 here on bottom and a 9 on top, so we'll multiply top and bottom by 9 here. And then right here, we'll put a 5, so we'll multiply top and bottom on this fraction by 5, and so you'll get 27 divided by 45 minus, then 5 times 7 is 35 divided by 45. And so this is still 3/5 and this is still 7/9, but now they have a common denominator, sort of like a common denomination of money, and so you can add or subtract them. So 27 of these minus 35 of these, so you're going to get a negative number. And so I just kind of count down by 27. So you go down by 10 and 25, you go down by 10 and gets you 15, and then you go down by 7, so it'll be negative 8 divided by 45. And you can check this on your calculator, which again, that's why a calculator is nice. You need to make sure you understand the ideas, because if you change these numbers to variables, the calculator can no longer do or work with that. So minus 7 over 9. And it's going to spit out an answer. And so it gives you negative 0.177, blah, blah, blah. And you can even turn it into a fraction by hitting math and then hit enter on math frac. And so it says take that answer and turn it into fraction, and you get negative 8 over 45. So it works. Nice. All right, so then on the next problem, now we're going to divide fractions basically. And so on this one, what you have is 11 divided by 2 minus 3 over 8. So what we need to do first is subtract the fractions on the bottom. So remember, 2 is really 2 over 1. So this is 2 over 1 minus 3 over 8. And so it's easy to get a common denominator when you're dividing by 1. You can just turn this into an 8 by multiplying top and bottom by 8. Okay, so that's still 2 because that's 8's cancel. But what you have here is 11 divided by 16 over 8 minus 3 over 8, which equals 11 all divided by, then 16 of these minus 3 of these is 13 of these. Right, so 16 eighths minus 3 eighths is 13 eighths. And if you divide by a fraction, remember you multiply by the reciprocal. So this is really 11 times, and then flip 13 over 8. So 8 over 13, which equals, so now when you multiply fractions, remember 11 is really a fraction, it's 11 over 1, you just multiply numerators and multiply denominators. So you get 88 divided by 13 for your answer. And again, it's really easy to check with a calculator. So if you think you may have made a mistake or you want to make sure you didn't, you can take 11 divided by, now remember, this is all in the bottom right here, so you need to put left parenthesis 2 minus 3 over 8 in parenthesis, and then hit enter, and I get out this number 6.769 blah blah blah. And you could even turn it into a fraction if you want. Hit math frac, and it turns it into 88 over 13. So that's what it's equal to. It checks. I know I did it right. All right, so make sure you're comfortable with adding, subtracting, multiplying, dividing fractions. And then we get to number 5. So number 5 is working with exponents when you have fractions in them. So it's a little tricky. First of all, you have to realize that that's actually in the exponent. It almost looks on the same line, but you can tell that those numbers are not the same size as the 1 and 6. So it's actually in the exponent. I guess it'd probably be better for us to rewrite this so it's really clear. Like 16 to negative 3 halves. And now these numbers have real meaning, so they actually tell us something, and it has to do with a language thing. So you either know it or you don't. Sometimes I make this comparison, like in a foreign language. We may say dog in English as dog, and in a foreign language you may say it as something else. And you may not realize that those two things are related unless you know the language. So the same thing is sort of at work here. It's like this 3 is sort of like the nice part, and this 2 is the bad part. So the 3 is actually means just cube it, whereas a 2 means take the square root. And then a negative adds in this little twist. A negative in the exponent means put it in the bottom. So what this really means, let's do a step by step. This is 1 divided by, so put it in the bottom, so we put this downstairs. So 1 divided by 16 to the 3 halves. That's what the negative means. And then the 3 means cube it, and the 2 means take the square root. It doesn't matter the order in which you do this, but if I don't have a calculator, it's really hard to cube it. So I'd probably take the square root first. So let me rewrite this as 1 over. That little 2 right there in the exponent means take the square root, so square root of 16, and then we're going to cube it. That's the easiest way probably to do this problem. So 1 over, and then the square root of 16 of course is 4, and then you cube 4, so you take 4 times 4 times 4, and you get 1 over 64. And so that's my answer for this one. Of course, you can check it, 16. You can hit raise 2. You need a negative, so don't hit the minus sign, hit the negative button right there. And then 3 divided by 2, and you see you get this 0.015624. We can convert it into a fraction if you like, and it is 1 over 64. Right. Again, be careful with this calculator. I know it tells you all kinds of things. If you read the instructions at the beginning, let's say that you would have read that the calculator is an amazing tool of approximation, but it can seriously rob you of the opportunity to learn how to do mathematics abstractly. And so basically you can not move forward much farther than pre-calculus. Calculus will be very difficult for you if you rely too much on your calculator when doing such basic calculations. All right, let's look at the next problem, number 6, and we're moving into algebra now. So you'll notice that we have fewer numbers and more letters, so more variables, and so we're going to work with the expressions. And we want to simplify this expression, and it's not too bad once you kind of get the hang of it. And again, it's really sort of what I might say something like quantitative literacy, like being able to see the symbols and understanding that where they're located is actually telling me things. So like when you raise something to the -2, remember that negative sign means put it where it's in top and bottom, and then of course whatever's in the bottom will move to the top. It just means flip things. So this is really the same thing as x squared and then y to the -1/2 divided by 5 x to the 3/2 and then y cubed. And then this is still all squared. I just took care of the negative part, so I still need to square everything. And notice how my x's and y's look very different. I'm not going to get confused between x's and y's here typically. All right, so now you square everything. So the idea is you square this, you square that, you square this, you square that, and you square that. And when you square something and it has an exponent, you just multiply the exponent. So 2 times 2 is 4, so this is really x to the 4th. And then the y, that's to the -1/2. So when you multiply it by 2, the 2's cancel, and you just get -1. Then I'll divide it by, now remember 5 has an exponent. We usually don't write it, but it's a 1. So when you do 1 times 2, you get 2, so you get 5 squared. And then x has an exponent of 3/2, so you multiply 2 times 3/2, the 2's cancel, and you just get x cubed. And then when you square y cubed, you get y to the 6. And so then that's equal to, since you have x cubed on the bottom and x to the 4th on top, some of these cancel, so you're just left with x on the top, divided by, and then 5 squared is 25. And because this exponent is negative, we're going to put y in the bottom, and so you have y to the 6 times y, which is actually y to the 7th. And so that's my final answer. It's really difficult to get this down in the beginning, but once you get it down, it's not that hard. And you have to remember that you need to rely on your sort of number sense. A lot of times when I square something like this, I'm not sure if I add exponents or if I multiply, but I can come up with a little silly example like, okay, what if I took x to the 1 and I squared it? Oh, of course that's x squared. Oh, so you don't add exponents, because if you add exponents, that would be x cubed. You multiply exponents. Oh, I see how that works. And you can even come up with number examples, which even make it sort of easier. Like if you took 2 cubed and you squared it, this would be equal to 2 cubed times 2 cubed, which is 2 to the 6th. So yes, you don't add exponents, you multiply exponents here. 2 times 3 is 6. And so that's why you're doing the things that you're doing here. On number 7, we want to write the expression as a power of x. And then this again is also another quantitative literacy type idea. You either kind of know it or you don't. There's 2 different notations for x to a power really. So you can write x to the n over m. Or we can use power notation, or we can use this radical notation, which is the mth root of x to the n. They mean exactly the same thing. This is sort of an earlier notation created by René Descartes, sort of the I think therefore I am guy, philosopher, mathematician, scientist, if you will. And then this is sort of more power, what we call power notation. And it was created by Isaac Newton, and it's really probably more important that you know this than that, because this has certain algebraic properties that we will be using later on in calculus to do problems. But you know that you need to know how to go back between the two, because they are so common in mathematics and other sciences. So let's do this one. What we want to do is we want to express this expression as a power of x. So how do we do that? So the idea is x to the 5th is already written as a power of x. We have x to the 5th, but we can rewrite the cube root of x squared as a power of x. So it's actually x, the good piece is the square, and then divided by, the root is the bad piece, so divided by 3. And then we can add exponents here. You have the same base, you add exponents. Now, that sometimes can be confusing. Like, how do you know you add exponents here? Well, it's just like if I had like 3 times 3. Well, we know that's 3 squared because there's an exponent of 1 and 1 there, and we just don't write it, and we add exponents. 1 plus 1 is 2. So that carries over in the algebra if you have just x, and the exponents are any numbers. And so when you add fractions again, you have to find a common denominator, so that's a 1. So I'll multiply top and bottom by 3, so we get 15 over 3. plus 2 over 3, which is equal to x to the 17. So you have 15 thirds plus 2 thirds, which is 17 thirds. So there's my answer for number 7. And so now we move on to polynomials. So these are other sort of common expressions. Polynomials are nice because it gives you a system other than the real numbers that you can add, subtract, multiply, and even sometimes divide in. So let's work this one out. So you want to do x plus 2 quantity cubed. So let's write out what that means. It means take x plus 2 times x plus 2 times x plus 2. So you do this 3 times basically. And you just start out with the first two. So I'm going to use my red color here. And it's real simple. We're just going to FOIL this out, or I'm just going to use arrows because first, outer, inner, last only works for this first multiplication. So we take x times x, and we get x squared. And we can take x times 2, and so we get plus 2x. And then we multiply out the next two, so 2 times x plus 2 times 2, so you get plus 2x plus 4. And this is still all times x plus 2. And so here, what I have is x squared plus 4x plus 1. And oftentimes, I'll skip this in between step, or plus 4, sorry. Plus 4. I'll skip this in between step and just do this in my head and write it down. But you can write it out if you want to. Then all times x plus 2. And then we'll do exactly the same thing again. All right, so this time, and there are a number of ways to do this. You can work left to right, or you can actually work right to left. It may be quicker to right to left, but I'm just work left to right just so you know it doesn't matter. So this times this, and this times that. So this is going to be equal to x cubed, because that's x squared times x, plus a 2x squared, so it's x squared times 2, and then plus, so now we do the next one here, so 4x times x, and 4x times 2, so you get plus 4x squared, and plus 8x. And then we do the very last one, which gives us what? So then you have 4x. Oops, I'm going to change colors here. So you do the very last one, 4 times x, and 4 times 2. So you get plus 4x, and then plus 8. And then when you simplify this, you collect together like terms. This is going to be equal to x cubed, and then plus 6x squared, plus 12x, and plus 8. And so that should be my final answer. There are ways to check if you did this right, especially if you have a calculator. You know, you could plug a number in for x and make sure that you get out the right number down here when you plug in the same number for x. But you can kind of see if you plug in 0, you get out 2 cubed, which is 8. So you plug in 0, you get out 8. And if you plug in 1, you get 3 cubed, which is 27. So you have 1 plus 6 plus 12 plus 8, which is 27. So you can see you can plug in numbers even by inspection, by simply looking at it and plugging in, see that you did it right. So you don't really need the calculator. But you can use a calculator to check it to see if you did it right or not. All right, then number 9, factoring and simplifying. So this is always really tricky for students. So factoring is sort of the inverse of what we did above. Above we could have multiplied out. Now we want to factor. And so to factor, you have to look for things that they have in common. And it's not really easy at first. A lot of times if you guys struggle with this, what I'll do is I'll do it with shapes first. Like, so suppose you have like square and you have this cubed times triangle and then minus. So you have square and then you have triangle cubed. And I say, you know, simplify this by factoring it, basically. What you want to do is you want to look and see what they have in common. So you see they have a square in common. Let's make this triangle squared. So you see they have a square in common, and this is cubed, and this is the first power. So what you do is you'll factor out a square. And then the triangles, they have triangle squared and triangle cubed, so you factor out the lowest power, triangle squared, and then you play this game, something minus something. And these somethings, when you multiply this something by that, you get this back. So you see you need to have a square squared. So square squared times square triangle squared, square cubed triangle squared, minus, then something over here times this is equal to that. So it's going to be equal to. And so what do I put here? Well, you have a square, you don't need that, but you have triangle squared, but you need triangle cubed. So you put a triangle right there. So this times that is this. So that's the factorization, if you like, of the thing above it. So when you look at this problem, you can apply the same ideas. It's not too hard. You look at the 3 and the 9, you ask yourself what kind of numbers they have in common. They obviously have a 3 in common because 3 goes into 9 and 3 goes into 3. And they have an x plus 1 squared and x plus 1 to the 1, so you always factor out the lowest thing they have in common. So they have x plus 1's in common. The lowest power would be x plus 1 to the 1. You just write x plus 1. And they have x minus 5 to the 3 and x minus 5 to the 4th. So I would factor out at x minus 5 quantity cubed. And then you play this game, something minus something. So let's figure out the something. What goes here times this is that? Well, you have the 3. You have x plus 1, but you want x plus 1 squared. So you definitely need an extra x plus 1 here. So x plus 1 times x plus 1 is x plus 1 squared. And x minus 5 cubed, x minus 5 cubed, so that's all you need. Over here, what do you need? When you multiply this, you get that. Well, you need a 9 here. You have a 3. So we'll put the number 3 here. That way 3 times 3 is 9. And then you have x plus 1 to the 1, and you have x plus 1 to the 1. So no need to add any extra x plus 1s. But you do need one extra x minus 5, because x minus 5 cubed is not x minus 5 to the 4th. But if you take x minus 5 times x minus 5 cubed, you do get x minus 5 to the 4th. So this times this is that, and this times this is that. And you can simplify on the inside, because the x's here are going to cancel somewhat. So you have basically x plus 1 minus 3x plus 15. And so the x stuff comes together, and the constant stuff here is going to come together. So 1 plus 15 is 16. And then this is minus, so x minus 3x is minus 2x. And you can even go further by factoring out a 2. So that's actually 2 times 8 minus x. And so my final answer, this would be equal to, I just carry this all down. So I have 3 x plus 1, x minus 5, quantity cubed, and then times 2 times 8 minus x. Oh, and I guess I would go even further because 3 times 2 is 6, right? So this is multiplication's commutative. So what you can do is you can move this 2 up to the front and get 6 x plus 1 times x minus 5, quantity cubed, times 8 minus x. And that's a great answer. I think that would be my final answer. If you want to be fancy, you could actually factor out that negative sign, so then it's always x plus or minus some number, so then you would get negative 6, x plus 1, x minus 8, and I'd write x minus 5 quantity cubed on the end because it's the more complicated expression. But either one of these it's just fine with me. It doesn't really matter. What's important is that you can actually factor up here like this. You understand how this is working, because we'll use this later on in the semester, and you'll certainly use it in calculus. I do this a lot in calculus. All right, so the last thing we want to talk about is solving equations. And we have a few types of equations. This is a linear equation. We're also going to solve a quadratic equation and a rational equation. So now to solve a linear equation, this one's a little difficult because you're dividing by 2, but it's really easy to take care of dividing by 2, or take care of fractions in general. What we want to do is we want to do something that's called clearing the denominators. So clear the denominators. And the idea is if you see a denominator, you basically want to multiply by it to clear it. So we'll multiply every single expression here, this one, this one, this one, this one, by the number 2. So what we get is 2x plus 12 is equal to, then 14 times 2 is 28, minus, and then when you take x over 2 times 2, you see how the 2's cancel? So you just get x. And so what we just did is we cleared the denominator. So we're left with just an expression that does not have any denominators. And so we can solve this for x. So let's move over the 12. Let's get rid of that. So minus 12 on both sides. And I'll go nice and slow so you can see all the steps. So 2x is equal to, you take away 10, you get 18. Take away 2, you get 16. So 16 minus x. And then we add x to both sides. And so we get 3x on the left is equal to 16. So then we divide both sides by 3 and get x equal to 16 over 3 as our answer. And you can even check this. So on my calculator, if I didn't think I did this right or I made a mistake, I would probably just do 16 divided by 3 and hit enter. And I can use this to test if my answer is right. So, I guess I just plug in for x here, right? So 16 over 3 plus 6. Let's do that. So 16 over 3 plus 6. So on the left-hand side, I have this number. And then if you plug in 16 over 3 on the right-hand side, you should get the same number back. If not, we did something wrong. So 14 minus 16 divided by 3 and then divided by 2. I get exactly the same number back, so I know I did it right. So I always like to check my equations if I'm when I'm solving equations, because it's easy to check. You just plug it back in if you have a calculator. If you don't have a calculator, then I kind of just go on to the next problem, hoping that I did it right. If I made a mistake, I know I shouldn't lose too many points because I had the right idea down. All right, let's look at this one. So this is what we call a quadratic equation. Now there are 3 ways to solve quadratic equations. You can factor, which is the easiest way to do it. I didn't say they're the best, but it's the easiest way. So if I can factor, I'm going to factor, or I could use the quadratic formula, which is probably what I would do next if I couldn't factor it, or I can complete the square. Now, I often don't complete the square because it's a bit tedious to do, but you should be familiar with the technique. So if you're not familiar with completing the square, Google it, and it'll remind you of what it is. So this one you can actually factor. So it's x plus or minus something times x plus or minus something equals 0. And the something, of course, depends upon the 21. So when I see 21, you have to immediately think the 2 most common factors of 21, and that would be 7 and 3. And then is there any way to add or subtract 7 and 3 and get a negative 4? Sure. Minus 7 plus 3 gives you negative 4. And so now I have this times that is 0. So now I immediately know x minus 7 is 0 or x plus 3 is 0. And so I add 7 to both sides, and I get x equal to 7. I subtract 3 from both sides, and I get x equal to negative 3. And you can test these answers by plugging back into the original equation. You'll see if you do plug in 7, you get out 0. If you do plug in negative 3, you certainly get out 0. All right, then the last one we're going to do on this math skills review is a rational equation. A rational equation involves basically polynomial divided by polynomial. And it's very similar to solving that first linear equation. The first step is to clear the denominator. So I'm going to multiply this by a single expression that will clear the 2 and clear the 2x minus 16. And you have to realize that 2x minus 16 is really a 2 all times x minus 8. And so if you multiply everything by this expression, it will clear the 2 and it will clear the 2x minus 16. So let's do that. So let's write this as 2 times x minus 8. That's what happens when you multiply this by 1. So you multiply here. And then when you multiply here, what happens? And let's just write this out so you can see it. So this is x, and let's just write it out. So that's 1 times. I have x over 2 times 2 times x minus 8. I normally skip this step, but I think it might be good for you to see it. Then minus, then you have x over 2x minus 16 all times 2 times x minus 8. And you can see right away what's going to happen. These 2's are going to cancel, clearing that denominator. And then 2x minus 16 is exactly the same thing as 2 times the quantity x minus 8. So it's going to clear that. And you're going to be left with this. So 2 times x minus 8 on the left is equal to x times x minus 8 and then minus x right here. And so what I would do is multiply this stuff out. So I have 2x minus 16 on the left. And then that's equal to x times x is x squared plus x times 8 is 8x. And then I have a minus an x. And so let's just clean that up. 2x minus 16 is equal to x squared plus 7x. And then let's move all this stuff over. So let's move over a 2x, and let's add a 16 to both sides. So let's write that on both sides. So minus 2x plus 16. And if we add these to both sides, what do we get? I'm going to draw a line here. So now if you add up these two columns, you get 0 on the left. And then on the right, you're going to get x squared, and then minus or plus. So you have 7x minus 2x, so plus a 5x, and then plus 16. And so now I have a quadratic equation. And unfortunately, this quadratic equation you can't factor. So if you look at 16, the most common factors of 16 are probably either 8 and 2, which there's no way to add or subtract 8 and 2 and get 5, or 4 and 4. And again, there's no way to add or subtract 4 and 4 and get 5. So what you need to do is use a quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And the trick to remembering this is simply just keep saying it to yourself over and over again. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you say it, every morning and every evening a couple times, you'll memorize it. And so it's going to be equal to, now b is positive 5, so b right here is positive 5. And so what do we do on this one? So we have negative 5 plus or minus the square root, and then b squared is 25, so 25 minus 4ac, so you have 4. A is just 1. There's a 1 here we don't write, but it's 1. And so times 1. And then times c, which c is, of course, 16. So times 16. And then that's all divided by 2 times a, so 2 times 1. So that equals negative 5 plus or minus the square root of 25 minus what? Minus 64. So minus 64 all over 2. And I'm looking at this, and I'm not liking it. And I'm not liking it because 12 minus 64 is negative, and square root of a negative number is a complex number. And I know I made this problem, and I made sure that it wouldn't be complex. And I see my mistake. So let me go back, and let's fix my mistake. Because mistakes happen. And because I'm getting a complex number, that means a number that you take a square root of a negative number, it becomes complex, or some people like to say it's imaginary. I know that there was a mistake here. And the mistake, maybe you saw it, and so you didn't make the same mistake, but this was supposed to be x minus 8. For some reason, I made it plus. So this should be a minus, which means this should be a minus, right? Which means over here, this should be negative 9. Right? So minus 8x, right? Minus x is negative 9x. And then when you take away 2x from both sides, this is actually a negative 11. Okay, so this is much better. So negative 11. And so now, what do I have? Let's use this eraser here, because this is going to change lots of stuff, because these numbers are going to be different. All right, so this number is definitely going to be different. So what am I going to get now? Now I have negative 11. And then I have 11 squared times 4ac. That's still the same thing. And then over here, you're going to have 121 and negative 11 plus or minus the square root of 121 minus 64, because 11 squared is 121. Much better. Okay, so it's no longer negative, at least inside the square root, so I know it's not an imaginary number. And so you get plus or minus the square root. And then 121 minus 64, it's like taking 120 minus 60. So it's like 60, but you have 61. And you take off 4 more, and you get 57. And that's all divided by 2. Whew, got it. Okay, so again, quadratic formula, easy to make mistakes. Now, you should be able to check your answer. So let's check our answer on this one, because this one's a little bit hard to check if you don't know how to do it right. So what you can do is you can put this answer in. And so I'm going to put left parenthesis. I'm going to check one of them. So negative 11. Let's fix this too. I made a mistake on this one. So There's more things to be fixed. That was minus 11x, right? So minus 11x. So if that's negative, and b is now negative 11, that means this is going to be positive. So we can take off that. All right, so notice that if b is negative 11, then negative negative is a positive. So that we can erase. So erase that, and so this is positive 11. That would have shown up when I tried to check it. I wouldn't get the right answer. So let's go back here. Let's plug this in. This is 11. Let's do the plus part. So plus the second square root of 57. In print, delete that. I have to get out of this. Square root in parentheses, all divided by 2. So that's one of the answers I found. Now, is this an answer to this equation? Well, we can just plug it in. So we'll take second answer and divide it by 2, because that's what this says to do. Take x divided by 2, and then take away the answer. So second answer divided by, and left parenthesis, because it's all in the bottom, 2 times the answer minus 16. So 2 times the answer minus 16. Now, if we get out 1, we did this right. If we don't, we need to go back and figure out what we did wrong. And we get 1. And so that's good. And now let me show you a little trick here. You can hit second enter to pull up the last entry, and then second enter to pull up the last entry. And if you want to check the other one, just for fun, once one works, you know the other one's going to work, because what are the odds? And so here you put a minus sign and hit enter. And you can even pull up, so 1.725 blah, blah, blah should be a solution to this equation. But you can even hit second enter again, and then second enter, since you use the answer button, this answer is actually now this number. And if you hit enter and get 1, you know that answer works too. All right, so this completes the math skills review.